All right, in this video, we're going to introduce vectors, and we're going to look at writing the component form of a vector and finding its magnitude. I realize some of you may have had or are currently in physics, so if you are or you were, a lot of this stuff is going to be review for you, so at least, it's nothing that's too out of control. But a vector is a mathematical object with both magnitude or length and direction. And it's represented geometrically by a line segment that has a direction to it. So the two key ideas behind vectors are that they have a magnitude or a length to them and a direction. So for instance, velocity in physics is usually one of the first vectors you come across, along with displacement and acceleration. The following shows an example of a vector v where we have from point P to point Q, and the direction we go is indicated by this first point here is P, which in this example has the coordinates 1, 2, and the point Q, which has the coordinates 4, 6. So going from point P to point Q, we go from the point 1, 2 to the point 4, 6. And if we were to reverse the order from P to Q and make it Q to P, we would instead have the arrow pointing this way. So the very first letter here is called your initial point, and the second letter here is called your terminal point. So much like an angle has an initial side and a terminal side, a vector has an initial or starting point and a ending or terminal point as well. Another way to denote vectors with, in addition to the P and Q, the initial and terminal points, is using a single lowercase letter with the little ray-looking vector pointed line segment above it. We also have another way, which is to use a lowercase bold letter. So if we were to see a bold lowercase v, that could be another way to indicate that this is a vector. So a lot of different ways and notations for indicating a vector. Right, the magnitude of a vector, either denoted with using single or double absolute value bars, so each one of these mean the same thing, it's just a matter of preference and style, is going to be the distance between the initial and terminal points, or in our case, the distance between point P and point Q. And you can use the distance formula that you learned in geometry class, or you can just use what I think of when I think of distance is Pythagorean theorem. So if we go from point P to point Q, we have to go from point P, we have to go over to the right or head east 3 steps or 3 blocks, and then head north or go up 4 blocks. So going from point P to point Q, we go over 3 to the right and 4 going up. And as far as our length goes, use Pythagorean theorem, 3 squared plus 4 squared is c squared, and we'll get a length of 5. So we have, in terms of representing this vector from P to Q, we can use what is known as component form. It looks very much like an ordered pair, 3 and 4, where x is positive and y is positive because we went right and up. If x were going 3 to the left, this would be a negative 3. The only difference between an ordered pair and this component form are these angled brackets that we use instead of parentheses. In addition to that, we have another form called unit vector form, which uses an I and a J in place of the component form with the angle brackets and comma. So 3i plus 4j for the point 3, 4. Or if it was negative 3 comma 4, it would be negative 3i plus 4j. So just as multiple representations of vectors in this section. So to find the component form for our initial point P and our terminal point Q, just take the difference in coordinates. So for instance, in our last one, from 1 to 4, just take the difference in coordinates. 4 minus 1 is 3, and then going up 4, 6 minus 2 is 4. So much like with slope in algebra class, rather than write it as a fraction or a ratio, we're going to write it in component form or as somewhat like an ordered pair. So our x1 minus x0, or we could use x2 minus x1, it really doesn't matter, y1 minus y0 or y2 minus y1, and we'll get our component form. If you wanted to use the I and J form, which I'm absolutely okay with you using, it would be x1 minus x0 or x2 minus x1 going in front of the I, so the difference in your x coordinates. And then y1 minus y0 or y2 minus y1 is going to go in front of j, the difference of your y coordinates. So we'll use each one of these forms interchangeably just to get you used to them. But as far as how I'm going to want you to answer, unless I tell you otherwise, I want it in a specific form, you're free to either use the component form or the I and j unit vector form. So example 1, we're going to find the component form of each and find the magnitude for our vector as well. So example 1a, we have the initial point A is at 2, -1, and terminal point B is at -5, 3. Well, if we subtract our x coordinates, here I'm going to use the component form. -5 minus 2, the difference in our x coordinates, also known as our horizontal component, and then 3 minus -1, the difference in y coordinates, or also known as your vertical component. And when we get that answer, we get -7, and 3 minus -1 is 4. So using the component form, you would write it this way. Using your I and j unit vector notation, you could write it this way. So either way is fine with me. As far as the magnitude goes, we want to use Pythagorean theorem on the horizontal component of -7 and the vertical component of 4. And as a friendly reminder, I recommend ignoring all negative signs so you don't end up with a negative distance or an incorrect distance at all. So 7 squared plus 4 squared, we evaluate that. 49 and 16 makes 65. And we cannot break down the square root of 65 and simplify it any further. So that's our exact magnitude, is square root of 65, is the distance between these 2 points. Example B, we have initial point A at -3, 2 and terminal point B at 0, 1. Once again, we're going to subtract our x's to get our horizontal component, subtract our y's to get our vertical component. So 0 minus -3 and 1 minus 2. 0 minus -3 is 3, 1 minus -2 is -1. So either 3 -1 or 3i minus 1j or 3i minus j. Either one of these 2 forms is okay. For the magnitude, again, ignoring the negative in front of the 1, 3 squared plus 1 squared is 10, and that's about it. So, all right, that about does it for this video. I will see you